Hello students, today we will try to understand the fascinating process of how neurons generate electrical signals. This process is called the action potential. This lecture will make us understand that how our nerves communicate and how we are able to get sensations. Action potential is a wave of electrical energy, or you can say a pulse of information which are sent from one point to another. The question is that how does this wave get started and what exactly happens inside the neuron to create this action potential. To understand this, let's compare the neuron to dam holding back water. Just as the dam holds energy in the form of water pressure, a neuron holds stored electrical energy due to difference in charges across its membrane. And to hold these electrical charges against their concentration gradient, we put in some energy. The dam holding back a high level of water, and the difference in water level creates stored energy, and this stored energy is waiting to be released when the dam gates open. When the gates open, water rushes through with force. This energy in the water comes from difference in water level, what we call potential energy. Similarly, a neuron's cell membrane separates charges. The inside holds more negative charges while the outside has more positive charges. This separation of charges creates stored energy known as the resting membrane potential. When a stimulus reaches a certain level, voltage gated sodium ion channels open up just like a dam gate. Sodium ions flow into the cell, releasing the stored energy and triggering a neuron's response. Like the dam gate that needs minimum level of energy to open, a neuron also requires a certain level of stimulus to begin an action potential. This minimum stimulus level is called the threshold stimulus. It can be reached through various signals such as chemical signals or pressure, or you can say some light touch. Once the stimulus reaches this threshold, sodium ions flow in and action potential is generated in the neuron. Let's now talk about 5 phases of an action potential in neuron. Each phase has a critical role in sending electrical signals. Let's start with phase 1, which is also called resting phase. In the resting phase, neuron is at its resting membrane potential, which is typically around minus 70 millivolt. Inside the neuron is negatively charged compared to the outside due to high concentration of sodium ions. Voltage gated ion channels are closed and the neuron is stable and ready for stimulation. What is in phase 2? Phase 2 is also called depolarization phase. When a stimulus exceeds the threshold level, sodium channels open up, allowing sodium ions to rush into the cell. This influx of positive ions causes the membrane potential to shift, moving towards zero and eventually becoming positive. This quick change from negative to positive is known as depolarization. Now, what is phase 3? Phase 3 is also called overshoot phase. As the membrane potential reaches around plus 30 to plus 40 millivolt, the inside of the membrane becomes briefly more positive than the outside, and this is the peak of action potential where the polarity of the membrane is reversed. At this point, sodium channels start to close. Next one is the phase 4, which is also called repolarization phase. In this phase, potassium channels open, allowing potassium ions to flow out. This outward flow of positive ions help to bring the membrane potential back to its negative resting state. This is called repolarization. And the last one is the hyperpolarization phase, which is also called phase 5. In this phase, potassium continues to exit the cell. Briefly, the membrane potential drops below the resting. This phase called the hyperpolarization phase, and it is temporary state where the membrane potential becomes slightly more negative than usual. So the potassium channels close and the neurons return to its resting membrane potential. And now it's ready for the next action potential.